This is a talk that was to fill in for a talk that couldn't do it, and it was originally scheduled or proposed as an hour talk, so I cut a bunch of slides out of it, but I'm gonna have to go really, really fast. So I'm gonna start early, and I'm gonna just tell you all that the full slide deck is out with Saintcon. Like when they send out all the slides, you can look at the slides and get all the detail out of it. But I'm gonna have to just whip through it really fast because I've got less than 30 minutes to go through this hour talk. So thank you for coming. I'm Andrew Brandt. I'm the director of threat research at Symantec, and I'm gonna talk to you about how an Android device that I use in my lab got infected with a drive-by downloader for the first time. I'd never seen this type of attack before. It happened back last March, this past March, I should say, and then some of the research that we did to figure out like sort of what was going on and who was behind it afterwards really led us in some interesting directions. And there's gonna be some IOCs in here. There's gonna be some network forensics and a little bit of endpoint forensics on the Android device, but I'll just jump into it. So this is basically the agenda, right? So everything I do in my lab, which I run out of my home, is recorded. So I've got a bunch of virtual machines, but also a bunch of bare metal devices, and they're all, the network traffic for these is all recorded on a gizmo that we sell, which I'm not going to get into right now, but just know that it's a full fidelity packet capture system that's very similar to one that you may have heard of. And in addition to the regular HTTP and other kinds of traffic that it can record and then reconstruct artifacts out of, it also, there's this other gizmo that's shown on the picture here called SSL Visibility Appliance, and it's basically a box that does man-in-the-middle SSL decryption on a very large scale. And then in addition to that, I have some wireless access points that all these devices connect to so that they're going through this piece of the network that is basically tapped. So this is one of my victim devices. It is a non-explosive Samsung Galaxy Tab 2. It was released about 4 years ago, and I bought this one at Costco for a couple $100. And Samsung, in their ultimate wisdom, has never issued a firmware update for this device. So its original firmware was Android 4.1, and the most recent version of CyanogenMod, which is a third-party Android that you can flash onto the device, is 4.22. So that's what's on the device today. When I do my testing, I usually use the stock browser app and not the Chrome that's available on the Play Store, just more vulnerable. We all know that there's a lot of vulnerabilities in Android. It has the man-in-the-middle certificates that are generated by the SSL decryption box. You have to install those, otherwise you can't do any of the certificate re-signing that it does. And it has a bunch of random apps. Basically, I want it to look like a real machine that people use so that when it gets infected, it doesn't just look like a stock device. So let's talk about what happened. So we have this mailing list that now, as you know, Symantec recently acquired Blue Coat, so I'm from the Blue Coat side of things. Blue Coat has this huge database of malicious and suspicious URLs and domains and IP addresses. Their reputation service is pretty much as awesome as it gets. And out of that system, there's a bunch of automation that kind of trolls around through the queries that the Blue Coat customers send into us in terms of looking up domains that are not rated or are not yet rated in the proxies on various customer networks. And then out of that comes this email that I get every single morning called Popular Site Monitor. And really what it's popular is kind of a euphemism. Basically, it means these are the sites that are generating the most traffic as referrers to bad things that we see. And so there's usually top 10, top 20 list of domains and where they're referring to. And I like to just drive machines right into those. So originally what happened was I got this list, and I will run down the list of sites and just type them in one by one into the browser and then tell the thing to go off to it. In this case, the very first one that I did pops up this screen that you can see here where it says, "Update now, please read, do not turn off or reboot your phone during update. Please try again later." And I see this kind of stuff periodically, and there's a lot of attacks that target Android that are kind of they're either rogue antivirus or other things that basically like try to these AV scams that we see today too, and tech support scams do a lot of this, where they'll pop up a full screen window to kind of make you think that you're looking at another app, but actually this was not the browser. So it pops this thing, and then the next thing that happens is, hold on, everyone, it's the cyber police. You've been caught looking at porn, and you can thank me now, but there was a really disgusting picture on this screen, and I have blocked it out. The white space at the bottom contains something really, really gross. And it says, attention, your device has been locked. Reasons indicated below. And then you can see here at the bottom, it actually has like some geolocation off of the GeoIP. It has the name of the device, and it also had the version of the OS that was running. All of this stuff, by the way, passed in the user agent string whenever a URL is queried. So typically, when we see attacks that target mobile devices, a lot of these attacks will, generally speaking, either deep link to something on the market, right? And they'll either pop a window open in Play Store that basically takes you to a page where it wants you to download something, or it might just initiate a download, which you then have to run. Either case, you then have to go through the normal installation process in Android, where you click the install button after looking at the long list of permissions that look really sketchy. And then the third type that we sometimes see are these, like, the support scam stuff, where it full screens the browser and it says you have a virus and you better call Microsoft right now and pay them $100 for virus removal, whatever. All that stuff, peanuts compared to what happened here. So first thing we saw was that warning message I showed you the screenshot of, and then the dorky ransomware, and then what? So first thing I did, of course, was I looked at this and thought, oh, this is another support scam, so I just rebooted the tablet. No, it came right back. So as soon as I did the login swipe on the screen, it basically came back. So I knew this was something different, right? It made me look at bad pictures, and it was telling me stuff like, there are activities that have been undertaken on this device that have been suspected to have violated of legal norms, a list of which is available below. There was a lot of information, actually, including a personal note from Jay Johnson, the head of the Department of Homeland Security. Thus, our performance is absolutely legal. Secretary of the Department of Homeland Security, Jay Johnson. Right. Gotcha. I love when this kind of stuff happens, because this is like, you guys just owned the wrong guy. So the first thing I did was I took a look at the session in security analytics. And among other things that you can see when you decrypt SSL, you can even see the type ahead queries. Like as you're typing things into the URL, into the address bar on the browser, you can see the type ahead queries. So you see it says, and it kind of keeps going. The next thing you see is the actual session of when it loaded the bad stuff. So I will break this down a little further in a minute, but what you can see is that most of the hostile traffic during this attack came from this one URL, directbalancejs.com. And you can see in the type column, there was a couple of different kinds of file types that were submitted, that were uploaded into the tablet during the attack. So also during this attack, there was some redirection that was happening around a bunch of different URLs, including this image tums.js. I don't really know why this string tums came up, but it seems like it might, and there's several URLs that have this string in the URL, and so I'm thinking that maybe it was just a Russian guy who just doesn't understand TH. He was trying to say, it's trying to make it look like a thumbnail site. So the first thing that happened was there was this exploit that was delivered to the device. Now, I'm not an expert on exploits, and I did not know what it was. All I know was the effect of it was that at the end, this application was running on the device. It started up at boot time. It was installed as root on a device that was not rooted. So somehow it had managed to gain root on the device and install itself so that it was the first thing to start up before even you could get to the home page. Right, here's slices of that, and what you can see from some of these strings that give you a little hint as to what's going on is there's a reference to XSL transform. And then there's some source code there of the actual exploit. The next thing that happened was that a bad Linux ELF application was delivered, right? So there's this file called module.so that came down, and when we actually looked at it, look, there's the ELF headers right there in the file. And a couple of AV engines, ESET and Tencent, identified it as something called Android Exploit Towel. So, okay, well that's kind of interesting. So there was one exploit and then a second exploit. And then the third thing was the ransomware. And the ransomware was delivered during a HTTP post response. So the infected device looks like it got this Linux ELF application installed on it, and then it did an HTTP post to direct balance.js, and then in the response was this APK. It was it was not the raw APK, it was like an APK with some header bytes at the very top, but you can see it says net.prospectus, and that turns out to have been the internal name of the ransomware. So looking at that, the last thing that it did was it did another post to the same site, and the post source said go to final.js track equals, and then there was a UUID that string that it posted. And the coolest thing about this was really cool. I'd never seen this before. I did a little bit of math, so you guys can follow along with me. It kind of starts in the middle where it says var f equals 0, and then on the upper left it says O equals f plus 0x d000, and then down in the bottom right it says x equals 0 plus 0x 200. So who can do math and figure out what that is? What's d000 plus 200? It's d200, right? So that's the location in hex in the file system is an offset of d200, where it wrote the string directbalance.js.com. So that was how it configures the malware. It actually hard codes the malware on the fly and writes in the command and control address into the file. I thought that was so cool. Really interesting stuff. So one of the things about that makes it interesting is, so we received the APK over the wire, right? You saw it was able to extract it, pull it out, take that artifact and run it in a sandbox. Well, the problem is that as the APK came down from the wire, it did not have its command and control URL. It didn't have that domain embedded in it until after it was written onto the file system. So just doing an extraction off the network like a competitor's product might do, you wouldn't get the full thing, and it wouldn't actually be able to do command and control. So in the end, what's good about these test beds is that they're set up with USB debugging turned on, so we were able to attach it to another machine, and then with USB debugging, we were able to go onto the file system and pull that thing off of the infected host. If you don't have USB debugging turned on your Android device before the infection happens, there was no way to get into those settings and turn it on. So it was just lucky that we were able to do that because we set it up that way. So we ran the sample through our sandbox, and we could see that it was creating it creates a copy of itself in a path called net.prospectus, called test APK. And then when our malware toolbox, our sandbox, runs it, it generates sort of like all of these heuristic detections of like bad stuff happening. And one or two of these things you might kind of expect, but then this combination, this number of different bad things, taken in the context of what happened, it's generally pants on fire time. All right. So we now know we've got the sample, we've got some information about its the internal name, the external name, where it came from. We want to expand the search. So one of the things that that Bluecoat has in its bailiwick is a really awesome reputation service for its URLs. So looking back at the security analytics piece of it, we kind of tear apart the whole session as it happened. And what we discovered is that there was this porn site loaded, and then what happened was there were two parallel tracks of one of which was a fake set of ad calls, or made to look like a bunch of ad calls, and the other was the actual ad calls that the porn site normally would load when you open the page. And so all of the things that are sort of inside of where the arrow is are the normal ones, but then those gaps between the arrows where they're pointing to, that was our parallel ad call track. And so what you see here is that it started with a call to puhtml.com, to a machine on that domain, then down to terraclicks.com, then down to pimpsure.com, and then paypop7.acquisition.pw, and then imagetumsjs.com, and then eventually directbalance.js.com. So all those 6 all those 6 domains were all involved in a redirection chain all the way down until it finally led to the exploits and the malware being delivered. All those 6 domains were hosted on 4 different IPs, 2 of which were in the same subnet, and you can see it was just 2 numbers apart on the same IP range. So definitely some interesting stuff there. So we have this tool that the research team uses. This is not something that's available to customers, but we just call it the Billiard Room, and it was written by one of our analysts, Waylon Grange, who's a super, super smart guy, comes out of the intelligence community, and like, what it does is it synthesizes all of the data that we receive about URL reputation and history from all of the different log collection systems that we have in our research network. So we do things like keep track. We have history going back almost 15 years of some domains, and like what their historical connection was to bad stuff happening. So the cool thing about this is you can just put in a couple of inputs, like the domain names or the IP addresses, and then stuff will start branching out of that about what we know about these things, like where have they been hosted, who's the registrant, what is the AS where the thing has been hosted, where has it been registered, and through what registrar is the DNS being done. So as you run this, initially it kind of pops up, and it's this really cool animation. I wish I could show it to you because you have to be on a fast connection to make it actually work, and I can't do that here. But it is really cool to watch it because it's like these bubbles will pop out and then float around and gravitationally kind of repel each other so that they're visible. And so initially what I did was I just stuck, so this is TeraClicks, right there in the center of that little cluster is TeraClicks. And the longer I let it run, the bigger the map gets to kind of show you the connections of stuff. And one of the things that's, let me jump back one slide here. So some of these icons that are worth noting is the ones that are radiation symbols are malware samples that we know are bad, like they've actually been detonated in the lab and we have a copy of them. When there's a red arrow coming out of the malware, it means it was talking to this place. And when there's a sort of yellow arrow coming towards the malware, it means that was the machine that was serving the malware. So when you look at like, a map like this, you can start to see those red arrows going back and forth, and you can tell that this is a pretty bad neighborhood on the internet, as well as these. So these double helixes, the ones that are in orange, those are what we call machine DNA, and that is, we do a lot of passive scanning of these machines after we get kind of requests about them, and we fingerprint the various characteristics of the server headers and other things that we know about these machines, and they get kind of concatenated into this one value called the DNA value. And so when you see multiple machines that share the same DNA, it basically means it's like running the same server code, the same version, like a lot of the same headers and HTTP response headers and stuff like that. So the shared DNA is a pretty strong indicator of even in otherwise unrelated machines that you can't tell are the same, that they're running the same code. So there's a lot of shared DNA. And what I kind of want to point out in this map is that there's basically only a couple of things that connect the big sort of mainland on the left and upper part of this picture with the little archipelago on the bottom right, and that is the DNA that's almost dead center. And just for reference, here's our 2 starting points that we started with. So TeraClicks on the left and PooHTML on the right. And this is all of what expanded out of this search. So we started to realize that in this same sort of cloud of machines that were all related to each other, that there were a lot of these machines that had very similar names that involved Tums or JS or Direct or Image, and the names started to pop out. So we started to see more and more of these, and we ended up coming up with this new list of network IOCs that came out of this. So that was pretty interesting just in and of itself, because as far as we knew, none of these URLs had ever been classified and had not been categorized. They were all just marked as uncategorized in our system. So we immediately went and flagged them all as source of malicious stuff. So the other thing I mentioned is I'm not an expert on exploits, and I didn't really recognize the exploits. But I have to give props to a couple of people who helped me with that. So one of them is Josh Drake. So he works for a company called Zimperium, and he does a lot of work with exploits on mobile devices. And I was preparing a blog post about this, and sent a copy of the blog post to a reporter friend of mine, and the reporter said, you don't know what this exploit is. Let me see if Josh knows. So he put the two of us together, and Josh immediately could tell that the exploit that delivered the ELF to the device was one of the leaked exploits that was leaked from the hacking team. So that group of guys who created basically a business in selling their services, writing malware for governments and sort of state-sponsored actors. They got breached last year in a wholly unceremonious way, and basically their entire data set was released out onto the wild. Well, this was the first time that we had ever seen someone weaponize one of the exploits, and the one that they weaponized in this case was that libxls transformer, libxlst exploit that was part of the package. The other exploit, which we had a hint about, where it said Android exploit towel, is something called Towelroot. So that was actually a publicly disclosed, well-known exploit that was used specifically for these Android KitKat and earlier devices to allow users to root their own device. So when we found this out, we realized, okay, well, this is pretty serious now, because now you've got people who have the capacity to well, at least they were able to use copy and paste and weaponize something that had been leaked and turn it into something, legitimately dangerous, and basically render anything that was in that vulnerable range of devices vulnerable. And suspect, they were then at that point able to load malware onto it. So we wanted to figure out, well, how long has this been going on? So, and it's worth mentioning that, like, yeah, we took apart that ELF that they had sent up, and yes, it was using Towelroot as its exploit, but it also had some encoded strings in it for doing command and control. And when we de-encoded those strings using XOR, and yeah, I guess that's one that I got to just try every single time now, you ended up with these strings that showed you the exact headers that we saw that matched the pattern that we saw of the post-infection beaconing. So in this case, what we understood was that when it did that HTTP post of report at the end of the infection, that was basically an indication that the infection was successful. And we used that as our sort of our guideline going back into the logs to figure out, okay, so who got infected? First of all, who was attacked by these? What types of devices were attacked? When were they successful was based on this, use of this post data. Right? So in the 60 days before we discovered it, we searched back even further, we saw that there were 7 different Android versions that had been targeted by this thing, and there had been about 76 cases of successful infection after it, meaning that we saw that post of /report at the end of the string of URIs. Most of the victims were in the US, but there was a whole range of international victims and affecting a bunch of different language settings and other things in their devices, and that there were more attacks than there were successes, and I mean that's a given, right? That in general there's going to be some failures, and really, like, what we noticed is that they were trying really hard. So we started looking back in those logs to see what happened. So the earliest time we saw these URLs being queried and that using these same URI strings that followed this pattern was back October 2015. So just about a year ago, this started happening, and it was very experimental at first and happening on a very limited number of machines. After that, but it only took 3 days after they started doing it until they had their first success. So on Halloween 2015, their very first success was this machine in Canada that got infected. And there was a little bit of improvement over time, right? So that first machine that was infected was running Android 4.1.2. And then, and again, we were able to understand what versions of Android were being infected because you can see the user agents in our logs. You don't get the full traffic like you can with security analytics, but in our logs, we can see the UAs. So we're looking at the UAs during the infections to sort of understand what it is that they're doing. So first there was 4.1.2, then a week later they got 4.2.2 and 4.4.4, and then a few days after that, you can see, like, incrementally they started infecting more and more different versions of Android, right? So in the end, we saw 224 unique user agent strings that indicated different makes, models of phones, versions of Android, et cetera, and probably somewhere over north of 500 infections during this time. Just now, again, this is just in the October until March timeframe. Right. Here's a list of some of the user agent strings that we saw, and you can see from them that they contain, the user agent will contain a version of Android, the language localization settings, right, the model number and build of the phone. And there is quite a lot of Samsung phones in there, but there were some Sonys and some Blues and some LGs and HTCs. I mean, it was really kind of a mix, and it really, all that mattered was if it was successful, it had to be within a certain range of Android devices. They had to be using browser, and it had to be vulnerable to these various exploits that had been leaked by hacking team. Right. So this is my last slide, and it was it's worth mentioning that the best part of this was the copy that was in the ransomware. Right. So there was this message at the very end of the ransomware screen, which is this big, long, scrolling screen, after it says how to pay and what everything was, avoid becoming a fraud victim. You mustn't give your prepaid card number or your bank account details till you are absolutely sure that the person is conscientious. Remember, if somebody asks you to buy an iTunes gift card, it is a scam. So they were telling you to buy a $100 gift card and put the code in a form and submit it, and then telling you right after that, if someone's asking you to do that, it's a scam. So not the sharpest marbles in the bag, let's just say. The other thing that's sort of worth mentioning is that, so we went public with this in a blog post. It got a little bit of press. Again, this was like March, early April earlier this year. Immediately, all of these sites went dark. And I checked last night, just to make sure before I gave this talk, and it does turn out that sites are still dark. A lot of them had their DNS just changed to localhost so that basically they can't be used at all. It appears that those DNS changes happened on the behest of the domain owners. They have not lost their domain ownership. Almost all of them were registered through private whois. So there's no way to really identify who was behind it, but we did identify one non-private registered domain that was kind of connected to this whole network of stuff, and it does appear that that registration email was tied to a bunch of other things that was in that list of IOCs that we posted up on the screen. Subsequently, now we're integrating with Symantec, and we now have more connections with their network. The other new piece of information that has come out since this talk was put together is that it looks like the owners of those domains and that network that they were on are connected to the Carburp family of banking malware. So they're a Russian banking malware gang that does this, really mainly attacking Windows. But they're a pretty sophisticated group, and they have a long connection to the various exploit kits that are out there for Windows. So it is really not surprising to see that they were moving their way into Android. But really what this tells us is that there's this vast ecosystem of mobile devices running Android, and even today they are still selling Android 4 devices that probably will never get a firmware update in their lifetime unless you really try hard to go on XDA developers and find some mod somewhere that you can install on it. And what that means is that there is a permanent and very large base of mobile devices that are essentially going to be never patched and perpetually infectable through these methods ongoing. And that's why I made the talk called why Android has become the new Windows XP, because it's basically abandonware at this point, and there's no way for these boxes or devices to be updated. So couple of pieces of suggestions. If you have a device that's running Android 4, use the version of Chrome that's available through the Play Store. It appears to be have been updated so that it is not vulnerable to the libxslt exploit. We also know that that was not the only exploit that was used, because some of these versions of Android that were infected were not vulnerable to that particular exploit, but they were vulnerable to other exploits that were part of the hacking team leak. So use regular Chrome and not the browser app that's built into it. Like, if you can, just disable browser, and just avoid going to sketchy sites on your mobile device, especially if it's running Android 4. So that's my time. Are there any questions, comments? Thank you, and I welcome your feedback. If you guys do the feedback forms, I appreciate it. We all like to hear when we do things good or bad. So thank you very much for your time.